everyone. All right, let's get started with the welcome for the workshop on rigorous evaluation of artificial intelligence systems here at HCOMP. All right, so this workshop is joint with the Data Excellence Workshop, and we're really excited to have this pairing between both groups for us here today. All right, give me 1 second. Okay. So for those of you who have joined us before at last year's HCOMP, AAAI, or an earlier, even earlier version of the workshop at the web conference, welcome back. And for those of you who are new, I want to give you some context for how the community has grown and how we wish to grow the community even further. So we want to be a forum for ideas, knowledge sharing, and just down-to-earth conversations about a number of issues. What makes an evaluation good? The value of improved data sets and collection methods, how to inform investment decisions for more robust evaluation procedures and data acquisition, and how this work can impact science and scholarship overall. We think that these are important and widely scoping topics and hope that you get excited about one or more of these topics. All right, so here's a look at the agenda for the day. Again, if you haven't seen this in any form, you can also go to the website, eval.how, H-O-W, /REAIS-2020 to see this program, as well as additional information. A brief walkthrough. So we have this introduction. We'll have an invited talk, then a break, and then a number of invited talks, all related to natural language processing and panel discussion, followed by another break and some reporting, a final invited talk, some lightning talks, and then we'll close. Okay, so you may ask, why rigorous evaluation? The major goals of evaluation for machine learning tend to center around two major questions. What is the accuracy, or what percentage of data points did my model correctly predict? And what is the generalization error, or how well does my model perform on some held out test data? Accuracy should be fairly clear, but the reason you want to understand generalization error is to determine whether or not your model has learned model parameters that can generalize, or instead, have you learned model parameters that are too specific to the data that it was shown? In other words, overfitting. Answering this question is important, but when researchers and practitioners focus evaluation on this narrow objective, we fail to prevent a number of problems in machine learning and AI systems. All of these problems have some relationship to evaluation, in my opinion, though we'll get to this broader view of evaluation on the next slide. I won't read these in detail, but the issues I've chosen to mention here are meta-science, scholarship, and reproducibility, which is concerned with whether or not our fields are producing rigorous science. Faulty metrics and reporting, which is concerned with how performance is represented. Brittleness and robustness, which is concerned with how changes to inputs to our models are able to easily break them, sometimes with valid replacements or very small perturbations. Data label sensitivity, so there's not always a single or small set of objective ground truth labels, while procedures and methods for inter-rater reliability, reliability and quality of labels have helped, we have a ways to go to embrace subjective labels. Ellen Voorhees and Courtney Napolis will address this in their talks. Real-world deployment and impact. There are a number of issues that the machine learning community has to A, embrace the impacts that they make, as research and practice are so tightly connected, and B, start large-scale measurement and mitigation of issues such as distribution shift, dataset representation bias, problem formulation, and more. To address rigor in AI systems, I believe we must look at them from a high level. Let's see here. Great. So expanding far beyond past test dataset validation metrics. Here we see a number of key features of typical machine learning systems. This includes dataset handling, model training, performance metrics, interpretability, and deployment. We will use these areas to frame the remaining bits for the intro. Dataset curation is the creation, gathering, organizing, and oversight of the dataset to be utilized in a machine learning process. It can include lots of things, such as pre-processing, augmentation of the data, splitting for validation, and more. I won't go as far in depth here, but our thoughts on datasets are that they should include a number of other more modern approaches that do impact evaluation, such as dataset augmentation, benchmarking, something we'll hear from Zhao, and label quality, again, addressed by Ellen and Courtney later in their talks. Let's move on to performance metrics, which include measures of accuracy and generalization error, as we previously mentioned, but can also include recent fairness metrics, human-centered metrics, and statistical tests. There are a number of fields that are quite ahead in the creation of communities surrounding metrics and evaluation. Both natural language processing and information retrieval have rich histories that consider heavily their evaluation metrics. Generative models and adversarial robustness represent two fields that are bringing novel challenges to evaluation. In generative models, you lose the ability to have pre-label ground truths, and adversarial robustness challenges the IID assumption in several ways. We want to bridge across communities and build on expertise from these and other fields to improve evaluation for AI systems generally. Oops, there we go. Great. I just want to briefly acknowledge that many of today's talks are from the NLP space. This is likely due to a number of reasons, so that previously mentioned history of evaluation research, as well as some of these unique qualities. It's inherently human-centered, massive amounts of data, and really interesting, well-defined tasks, as well as just the personal connections of the organizers and the HCOMP community's strong attraction of language researchers. So that's some of the reasons that you'll see a lot of language talks today. But I think it's a great fit for evaluation in a lot of ways. So interpretability might be surprising to you on an evaluation talk, but it's indeed strongly connected to evaluation, in my opinion. Interpretability enables evaluation of the implicit rules in the model by translating them to a more human understandable form. And in that form, we can compare to expert opinion and heuristics. So I'm happy to talk more about interpretability offline, but I do want to mention that meta evaluation is a strong research topic in this space. One possible reason for that is that explanations are often built on top of a complex model. And so if you're using your complex model as ground truth, what that means is that you have an infinite number of labels that can be treated as ground truth. All right, so finally, we'll discuss considerations for deployed systems. Oh, sorry. do not know what happened there. All right, deployed systems. So I'm excited to see the talk from Basmira Nushi, and she will address some of these questions later in this workshop. One consideration for deployed systems. There we go. One consideration for deployed systems are that our models and systems are related to reality or trying to represent reality, really. And so it's one thing to create a model as a purely academic pursuit, but quite different if one claims to make a working model that can be used in the real world. So here we see the difference between decision space, which is our real world target, construct space, which is our dependent variable, and observed space, measurements. Another important deployment related topic is tools. Tools for evaluation of real-time models, which often means time series and streaming data instead of the static data sets that we're used to using as academics and learning. So here's one project that I've been working on to address evaluation and monitoring in this kind of real-time streaming data paradigm. All right. And we must endeavor to challenge the broader community on their assumptions and held convictions. So one of my favorite examples is the Inclusive Images competition out of Google in 2018. There, they very openly challenged researchers to train on a data set that was clearly geographically different than the test and validation sets. So this violates the assumption that data for test and training are drawn from the same distribution, but it's an important step toward acknowledging the realities of deployed systems and the distribution shift that we see. All right, so finally, our goal at REAIS is to increase awareness and advance rigorous evaluation among researchers and practitioners. If you wish to become even more involved, consider joining us in our next steps. So that's writing a report from today's findings, and then later joining the program committee or organizing team for one of the next workshops we hold. And that is all for me. Thank you and welcome to the workshop.